EMPulse is a new approach to locating electromagnetic compatibility issues. EMC testing is mandatory on all new designs of electronic equipment. These final tests are time-consuming and costly. EMPulse offers a simple, effective approach to locating and preventing problems associated with ESD and RF immunity. EMPulse can quickly assess the effect of electromagnetic fields on PCBs, individual circuits in large enclosures, ribbon and internal cables, the effectiveness of enclosure shielding, external cables and connector shielding, transformer magnetic shielding, small complete assemblies. EMPulse can also be used for production batch testing. EMPulse has been designed with intuitive controls that can be operated using just one hand, leaving the other hand free to operate and adjust other equipment such as an oscilloscope. This is the EMPulse kit. It comprises of the EMPulse body, powered by internal batteries, and a sensor you can use with an oscilloscope called EMCheck. There is a smaller near-field probe called EMLocator, a large general scanning probe called EMScan, 2 cables to connect the tool to an oscilloscope, and finally the operator's manual and a charger. Using EMCheck, we will now verify the pulse waveforms generated by EMPulse. With the EMCheck sensor monitoring the magnetic field, we can see the positive and negative pulses. Switching the EMCheck sensor to the electrical field, you can now see the positive and negative pulses. Here is a unit simulating a product that failed when it was subjected to the standard CE ESD immunity test. Normally the LEDs flash in sequence, but during the immunity test the LEDs behaved erratically. We will now check this unit with the EMPulse power set to high and with frequency set to random. By pressing both the positive and negative buttons on EMPulse, the unit generates alternating polarity pulses of electric and magnetic fields. We are now scanning in both directions whilst looking for the EMC failure symptoms. That is what we are looking for. The LEDs have gone out of sequence. We have now replicated the symptoms of failure that occurred in the CE immunity test. The circuitry is being affected by the electromagnetic field from EMPulse. Exposing the PCB, we can now scan the problem area, which appears to be a ribbon cable. By reducing the EMPulse power control, we can sweep closer to focus more precisely on the problem area. It seems to be a single cable in the ribbon, which is only affected by the positive field pulses. To allow closer location of the area, we have now attached the smaller EMLocator probe. By using the short section and the tip of the probe, small areas can be accessed. By reducing the power control and sweeping closer to the ribbon, a single conductor in the ribbon cable can be identified. Having connected the EMPulse trigger output to an oscilloscope trigger input, we can now stimulate the problem area using EMPulse and simultaneously probe the suspect conductor in the ribbon. The induced field pulse can be seen on the scope display, confirming this is where the problem is located. For clarity in this demonstration, an easily seen ribbon was used. In fact, EMPulse can be used to precisely locate very small tracks on a PCB. EMC standards are often changing. EMPulse can always be there to give a pre-compliance check for electromagnetic immunity. Potential ESD and RF immunity problems can be located and dealt with before final testing. It is more cost-effective to deal with the source of the problem than trying to shield a sensitive design. EMC testing can cost thousands of pounds. Product failure can cost tens of thousands. The rapid assessment of issues and repeatable results make this handheld instrument an indispensable tool for any engineer.